So this is how you balance a nuclear reaction. And there are several of these particles, we're not done yet, that we have to learn, i.e. put on your piece of paper and have it handy for the quiz, put it on your notes. We have to learn these in order to be able to complete them. So let's do another one together. Are you guys filling this in as we go along? All right, you're welcome to fill in these answers. All of these are multiple choice. You're welcome to fill these in as we go along. Now we've got one that's a little bit more complicated. There's our X. And now we've got another symbol. Let me go back to the blue. We've got a P. A lowercase p is a proton, just like the proton we find in the nucleus, which has an atomic mass of 1, a mass number of 1, and an atomic number of 1. So a proton looks like this. We see our buddy the neutron again, which we saw up there. And then we have this new symbol. This is an alpha particle. And an alpha looks like this. On your screen, it may look a little different than on my screen, just depending on the font substitution. It's kind of like a proportional sign, but it's a little shorter. That's the alpha particle. This is the alpha particle. When scientists studied the alpha particle, they knew its mass, they knew its charge, they knew what numbers to put. It is a 4 and a 2. As they studied it, and as they studied it further, they discovered that it was simply a helium nucleus, no electrons, with the 4 and 2. If you go up, helium's atomic number is 2. The most common isotope is 4. It is simply a helium nucleus without its electrons. It does have a +2 charge, but this doesn't matter. We do not have to worry about charges. Although sometimes it is written, we don't have to worry about charges in nuclear reactions. So there's two more particles that you have to memorize or else keep on a piece of paper in front of you. All right, so let's do this one. Here we go. 234 thorium. Let me write it out here so I've got a little bit more room. Plus a proton 1 and 1 gives me an X. This is what I'm trying to find. Plus 3 neutrons. Neutrons are 0, other way, 1 and 0, plus an alpha, which is 4 and 2. You do have to worry about coefficients. Coefficients act just like they do in chemical reactions. That means I have 3 neutrons. So we saw thorium up above, otherwise we'd go look him up. He is 90. All right, we saw him up here, so he's 90. Otherwise, we'd have to go look him up. And then to balance it, on the left, I have 91. That means on the right, I need to have 91. 91. So whatever is with X plus 3 times 0 for my neutrons, which is still 0, I don't have to write it, plus another 2 for my alpha particle must all add together to be 91. So this guy, let me change color, this guy must be 89. All right. I'll balance my top. I got 235 on top, 234 plus 1. So over here, I have whatever X is, plus 3 times 1 for my neutron, plus my 4 for my alpha, must all add together to give me 235. So what is that? 235 minus 4 is 231, minus another 3 is that 228? Don't be afraid to use your calculator. Yep, 228. So it's X 89, 228. All right. Now we saw 89 again. We're not getting very much practice looking these up. That's okay. You don't need a whole lot of practice. All right. We saw 89 above, otherwise we'd have to go look it up. It's actinium 228. So scroll down till you see him. There he is. What do you think so far? Easy peasy?